Welcome, welcome. Thank you so much for joining us today. We're thrilled that you could be here with us. For those of you who don't know me, my name is Leah Izakovitz. I'm the Executive Director here at Women+Power, and I'm going to get us started on this event. Just a notice here, we will be recording this session today, and we do value your privacy, and you can visit our website for more information. For today's session, I just want to thank everybody for being here today and for our exciting panel presentation, Inverter-Based Resources and Grid Reliability, Navigating the Future of Electricity. In terms of the agenda, I'm going to do our welcome and introductions and also introduce our moderator, who will then introduce our panelists. From there, the panel presentation will be just under an hour. We will then have time for some Q&A. We are going to try to finish at 1 p.m. so that people can view this session within their lunchtime break. So put your questions into the Q&A box, and we will strive to get to as many questions as possible. Again, if you need any support, please reach out to me via email. And after the event, I will be sending out a survey, so please do respond as your feedback is valuable and it helps shapes the programming and different initiatives that we do. Before we get started, I do want to start with our land acknowledgement. We acknowledge that we live, work, and gather on the traditional territories of the many First Nations, Métis, and Inuit people who have cared for these lands for generations. In what is now Alberta, we recognize Treaties 6, 7, and 8 in the historical Northwest Métis homeland. We honor the knowledge of all elders past and present and make this acknowledgement in the spirit of reconciliation and gratitude. Sorry about that. I just want to share a little bit about Women+Power. Women+Power is an organization that strives to empower women in Alberta's power and energy industry to reach their full potential, both professionally and personally. We also welcome men in the industry to engage with and support our community. We strive to develop a supportive and influential and accessible community through events and programs, PD, and both online and in-person events like we're doing here today. We strive to create an environment where women feel empowered and have access to information and resources and services they need to succeed in their careers. And we strive to collaborate with our sponsors and partners to support and establish goals and initiatives related to diversity and inclusion in the workplace. I do want to take a moment to thank our sponsors. Our financial sponsors are amazing. They're our supporters, and we wouldn't be able to do the work that we're doing without them. And so we are extremely grateful to our founding sponsors, ATCO and NMAX, and of course our gigawatt, our megawatt, and our kilowatt sponsors. Thank you. I would now like to introduce our moderator. And so our moderator today is Bree Fox. Bree Fox is a seasoned industry leader with over 20 years of experience in Alberta's power sector. She's a passionate advocate for leveraging a full range of technologies to support energy transition. Throughout her career, Bree has built a strong reputation for excellence in, in leadership, project execution, and strategic business planning, all of which she brings to her current role as Director of Customer Projects and Services at the ISO. She plays a key role in enabling development for both generation and load across Alberta, while ensuring the reliability and resilience of the provincial grid. She is also a founding member of Women+Power, so it's awesome that she's moderating today, and she's committed to advancing diversity and inclusion within the energy sector. Driven by innovation and collaboration, Bree continues to shape the future of Alberta's energy landscape with a clear focus on sustainable growth and long-term impact. Welcome, Bree. I will now hand it over to you.
Okay, amazing. Thank you, Leah. Just to confirm, you can hear me, everyone else can hear me. Thumbs up. All right. So welcome everyone to our virtual panel on IBRs and grid reliability. There are many things you can be doing over your lunch hour, and we are very grateful that you have joined us today. So we have an outstanding lineup of panelists for you, and we're very excited to share learnings and insights. As Leah had mentioned, there will be a short opportunity for questions at the end of the session. So if you can pop them into that Q&A chat box, we will get to as many of them as we can once the main panel is finished. Okay, so without further ado, let's meet our panelists. I don't want to get this wrong, so I'm going to read as Leah did, as these are so well articulated. So our first panelist is Astrid Schneider. She's the Director of Engineering with Projects at AltaLink. With over 2 decades of dedicated service at AltaLink, Astrid brings engineering and leadership experience to her role overseeing engineering teams responsible for planning and design of new transmission facilities. In addition to guiding the development of AltaLink's infrastructure, she leads the company's quality management and engineering standards, ensuring technical excellence across all projects. Throughout her career at AltaLink, Astrid has held a range of leadership and engineering positions across both project execution and operations. The breadth of experience has given her a deep understanding of AltaLink's business, its people, and its customers. Astrid is known for her commitment to employee development, operational excellence, and exceptional customer service. So welcome, Astrid. We are very fortunate to have you here today with us.
Thank you, Bree. Thanks for having me.
And you're nice and clear, so that's perfect. Okay, our next panelist, I promised I wouldn't butcher his last name, so Mike, I'm going to try my best here. Mike Schronenberger, got it right, the Vice President of Development and Markets at Infinite. So Mike, I'll skip that first part, leads the company's project development, regulatory, and market integration strategies. With over a decade of experience in engineering, project development, and smart grid technologies, Mike brings a deep understanding of both oil and gas and power sectors. He holds a Bachelor of Science from the University of Calgary and is a registered professional engineer who has his PhD. Since joining Infinite over 4 years ago as a facilities engineer, Mike has advanced through several key roles, reflecting his strong leadership and technical expertise. He now represents Infinite in regulatory working groups and plays a pivotal role in advancing energy solutions that support a resilient grid. A strong advocate for equity, diversity, and inclusion, Mike has been a panelist with Women+Power and is actively building an inclusive development and markets team, including advancements of women in leadership roles. So if you are a woman online and you want a leadership role on Mike's team, he's the guy you want to contact. All right, and then the last but not least panelist, so thank you, Mike, for joining us, is Tracy Spratt, Manager of the Office of Chief Engineer at ENMAX. Tracy leads a team that provides technical direction for ENMAX's Power's wide scope of transmission and distributed regulated business. Tracy has a Bachelor of Science in Electrical Engineering and is a professional engineer and a responsible member with APEGA. Having been with ENMAX for over 20 years, most of it is spent leading technical teams, Tracy has a passion for improving process, inspiring collaboration, and enhancing the development of technical capabilities of the ENMAX team through mentorship and training. She is chair of the board of the Alberta Industry Consortium, APEC, as well as the Electricity Canada's Grid Modernization Committee. So thank you, Tracy, for joining us with a couple of hats today that I think will be really helpful for the conversation.
Thanks for having me.
Okay. So before we get into the meat of the discussion today, we're just going to do a little bit of get to know our panelists. This will be pretty quick, it'll be pretty punchy, but just something to maybe level set where we're at and who we have on the call outside of a formal bio. So we're going to go in the same order for all three, so this is fast. So we're going to go Astrid, Tracy, Mike. Only because that's the order you're on my screen. 3 questions, keep it punchy, and then we'll get into IBRs. So the first question, how long have you been in the electricity industry? Astrid.
Over 26 years, various engineering roles and leadership roles, mainly in transmission utility.
Amazing. Tracy.
Yeah, 24 years and 21 years with ENMAX.
Awesome. And Mike.
I'm the newbie. It's only 4 years in electricity.
But you have diverse experience, which you're bringing to the conversation. Yep. Okay, so you can see we have some really, really great knowledge, call it north of 50 years of collective experience on this panel, minus mine, but I'm not part of the knowledge in this section. So thank you again for joining and for sharing your knowledge with us. Okay, another question. What inspired you to step into leadership? Astrid.
I'm a team-oriented person, so I enjoy the challenge of building and developing teams and removing any obstacles such that the employees can be put in a position where they can be successful. I also enjoy solving problems in real time and implementing new processes and tools that result in long-lasting improvements.
Amazing. Okay, Tracy.
So initially it would have been encouragement from others, but ultimately it was my desire to be able to have more influence on change and a greater capacity to support my team members. And since then, what's kept me in leadership is really my passion for developing people and empowering teams.
Thanks, Tracy. And Mike.
Mine's very similar to Tracy's, to be honest, but it is really to help increase my contribution. You get to be involved in more stuff as a leader, and then you get to develop teams and you get to bring new people in and help them grow into what they can be. So
Wonderful. Yeah, industry is very fortunate to have wonderful leaders such as yourself to look up to learn from. So thank you for taking those roles. Okay, and in the spirit of leadership, this is the last pre-IBR question, but I think important to get to know each other and think about our own careers. Which leader, past or present, has inspired you the most and why? Or maybe been the most influential to you and why? So same order, just for simplicity. Astrid, I'll ask you to start.
Yeah, so I don't know how many people know Robert Greenleaf, but he was an American business executive for over 40 years with AT&T and the founder of the Servant Leadership Movement in 1970. What was great about his career and his movement is that he changed and reshaped how leadership is understood in the business and how he saw it as prioritizing growth, empowerment of teams, removing barriers, offer guidance, and emphasize employee well-being and customer satisfaction above all. So he's my inspiration.
I love that. Tracy?
And I've been inspired by many leaders, but one leader that I will discuss inspired me, but also I would say even more so challenged me to grow the most. So under his leadership, I really did grow, but it wasn't always easy, but it was so valuable. So he had very high expectations, but also provided trust, and ended up being an advocate and sponsor for me in my career, which provided me for opportunities that others might not have considered me for. So I'm really grateful for that. And I try to take a sponsor role for others in helping them develop their careers.
Amazing. Okay, and Mike?
mine would be my first boss in my job out of university. He owned the business, and at the time I didn't appreciate it, to be perfectly honest, but every day I appreciate more and more of what he did. And just it was truly like a people-focused, team-focused. The company succeeded as a whole. It was never about individuals. And then just constantly challenged me to think outside the box. I was never allowed to say no to a customer, so that was difficult, but I have a lot of respect for what he was trying to teach me.
I love that. A good theme of sort of being challenged and finding the best in ourselves, through others. Okay, so let's get to the task at hand here. We're going to level set a little bit. There's a wide range of audience members on this call. So to level set, we're just going to sort of revisit here IBRs, grid reliability. What exactly are we talking about? So Mike, I'm going to start with you in this conversation. As the developer on the call, you're intimately familiar with IBR technologies, and I think one specifically, but to help level set the conversation, when someone says IBR, it's inverter-based. What does that mean? And maybe it's most plain language, and how is that different from conventional generation?
Yeah, for sure. So I would start with conventional generation. I think that most people will be comfortable with that. When you think about gas generation, coal, hydro, you have synchronous machines tied to a generator directly to the grid. So in the simplest form for me, I always think about is they're generating power directly into AC and alternating current, and that's what the grid takes. So you're directly coupled. For the reliability aspect, that's where you hear about providing inertia. You have a physical machine coupled, so to change the frequency, you have to change its speed. So you have momentum, inertia behind it to change. So frequency can't just change immediately. Switching to an inverter-based resource, you're now typically create or generating power or storing power in DC current. And so you have power electronics that convert it to alternating current, and that's where your inverter is. It's a power conversion. So now you're not directly coupled in how you're storing or creating generating the electricity to what the grid is actually taking. So it's decoupled. So you don't inherently provide any inertia anymore. There's obviously a lot of complexity around all of these things, but in general terms, that being said, there is ways to provide synthetic inertia with inverter-based technology, where if you can respond fast enough, you can make up for supply and demand deficit quickly and provide the same net impact to the grid as synchronous machines.
Okay, awesome. We're going to get into that synthetic inertia bit when we start talking about reliability. Astrid, if you can reflect on the transmission perspective and operating transmission lines, how do you see IBRs different or frankly the same as conventional generation from a transmission operation perspective?
Thank you, Bree. So there is a few different key differences between the conventional and the IBR. So if we think about the IBR being a solar or wind generator, could also be a battery. But if we focus on, so Mike talked about the inertia, so I kind of wanted to zoom in a bit more on what that is, just to level set the audience here. So from if we translate that to a lay terms, it's like being in a merry-go-round and then you try to speed or slow down. It's not gonna do it because it's gonna pose that change. So that's what the conventional generator used to offer at no additional cost. They provided this inertia or resistance to change when there was an imbalance between supply and demand, just to slow down the decay of the frequency. And why that is important is because if the frequency deviates from standard 60 hertz in Canada, it could cause equipment to be damaged. And it could also actually cascade into multiple generators in the system being disconnected. So that's a very key requirement from a transmission or electric grid perspective. And a key differences between the IBR type generation and the conventional generation. If we go down to the fuel, which explains another few differences there. So the conventional generations, they used to use coal, gas, natural gas, nuclear, or hydro. The IBRs are either solar or wind, or it could be a battery as well. So if we focus on the wind and solar, the fuel is actually provided at no cost. And then because the fuel is provided at no cost, what this does is that those generators can actually offer a market price that's lower than the conventional generators. So it could cause an influence into the market price, but at the same time, with the lower market prices, it could actually deter the existing conventional generators from remaining online because they could not recover the cost of their operations. So the price could fluctuate again in the opposite direction. So the addition of the new IBR type generation and the type of fuel that they use, it actually drives fluctuations on the market pricing. So that's another key difference there. Other difference would be around voltage control. Conventional generator used to provide voltage control services as well with no additional cost. IBRs can actually provide voltage control depending on whether they're grid forming or grid following. But in general, most of the IBRs or generators in our system currently, they're all grid following IBRs, which means that they actually use the system reference voltage to basically, maintain frequency and voltage based on the system information. So what that means is like if the system is weak, these generators could actually disconnect or they can start oscillating and causing voltage oscillations on the system. So that's another key difference. And maybe just the last one to close. Another one is deployment. So IBRs can actually be easily deployed compared to the conventional generators. Conventional generators are usually, take a long time to build, to deploy. They're also more centralized. So there wasn't, we didn't have as many generators. With the IBRs, they're easier to deploy. They could be distributed. We have seen actually in our transmission system, we have seen a growth of generation, especially IBRs. On my last math year that I did between 2019 and 2023, we saw an increase of 60%, up to 200 if we include any distribution connected and transmission connected IBR. So that's a significant amount. And there is in Alberta specifically, there is a cluster of wind and solar generations, especially in the south of the province. And this cluster, what it does is it creates system congestion in a region. And then to explain this in lay terms, so if, for example, you had a highway and this highway provides access to various communities from point A to point B, if you keep adding communities without spending the highway, then it would drive congestion on the highway. So that's essentially what the cluster of generation on a specific part of the province where the wind is there and the sunlight is there. It actually has created some congestion on the transmission system as well.
I like your analogy on the highway. The highway's full, it's congested, no more cars. That was really helpful. Thank you, Astrid. So Tracy, putting on your NMAX hat, is there anything different on the distribution network that you've seen with the increase of IBRs, or maybe any other sort of nuances that are different from the distribution system versus the transmission system that Astrid had spoke to?
Yeah, I think so NMAX hasn't really seen a large number of large IBRs, so over 5 megawatts, just because of our urban utility and spaces at a premium. Fortis definitely sees a lot more of that. But we do have a few. But one thing that we are noticing, just that is a bit unique to us, is the requirements for submitting settings and understanding what are the connection requirements that need to go to the system. And so recently we have collaborated with EPRI and 10 other utilities on a project to have commissioning hardware and software developed that will help us ensure that customers' DER settings are as expected prior to energization. So that's quite exciting for us because we have had some various different instances, and there's different knowledge when you're talking smaller IBRs about what that takes to get connected to a system.
Amazing. Okay, so we've talked a little bit about what an IBR is and sort of how technologies have changed. Let's dive into that a little bit here. No doubt the supply mix in Alberta has evolved over time. The phase out of coal, increase of renewables, I think it's just fair to say the technology mix has changed significantly since the early days of deregulation. So today in Alberta supply mix, just a couple stats here, we have 5,600 megawatts of wind, 1,800 megawatts of solar, and 190 megawatts of energy storage, largely thanks to Infinite and to Mike. So Mike, I'll start this conversation with you on just sort of the change of supply mix and the change of supply demand balance in Alberta. What are the key drivers in the past decade, putting on your developer hat here, that have increased our IBRs in Alberta? And then the follow on that is, what do you foresee for future IBR development?
Yeah, so it's a bit of a complex market, obviously, in Alberta, but there's been a big driver in the offtake market has helped build out a huge amount of renewables. There's an external revenue driver, which is pretty critical for most IBRs. As Astrid said, they're not a controllable resource, so playing in an open energy market where we're reliant on the price of power is difficult, even when your fuel cost is very low. It's difficult to manage. So an offtake market where you can monetize renewable credits, you can monetize off-takers that want a clean energy source. That's been a huge boom of building out a lot of the IBRs. That tied with then Alberta's open, so free, as you know, people can just apply and get into the queue or into the project list and get a project going. That's very difficult in a lot of other provinces. You have to typically wait for a procurement or a need for that type of resource to be asked for by the Crown Corp or the central planning. So we're very unique in that regard. It's allowed it to grow very rapidly. If you can build a business case for it, you can build it in Alberta. So that's been a huge uptake in the market. That paired with, as it's grown, technology costs have come down drastically on all the technology types. Storage is a bit of the lagger. We're now seeing the pricing come down, but it's a lot newer than wind and solar and not as built out. But really that ability to secure a long-term contract gets these projects built. You can go get debt financing. You got tons of support to build them. It's easy at that point. Now the question on the future, I think it's a bit different. Since we've had such rapid growth, it's got to level out. We got to figure out where the right balance is and have all the supporting infrastructure to manage that. There's the reliability concerns that we're seeing now and a lot of different market aspects. We don't know what the load mix is going to look like in the near future with potential data centers and just load growth in general. So difficult to say what the future looks like. If there's a market for it and a revenue stream, it will continue to get built.
I love that. I also will thank you for correcting the project queue to a project list. It took me a few months when I first came to ASO to say, it's a list, it's a list. Everyone on the call, it's a list, it's not a queue.
Old habits, sorry.
Me too, it's all good. Okay, awesome. So Astrid, as these generation technologies, they've evolved, obviously, in Alberta. What kind of changes have been made to the transmission system to keep up with these changing times? Or maybe follow on that would be, what future changes do you think are required to keep up with a robust and reliable grid in Alberta?
So I would say, so starting with the from an operation perspective, so we talked about system congestion. So some of the changes that has been done are implementing remediation schemes. We used to employ these in the past, but not to the level that we are now. And these remediation schemes, they actually help to eliminate or reduce the amount of curtailment of generation in preparation for what we call next contingency. So if you're operating on system normal, and then all of a sudden you lose a line, the RAS is there to kind of help out to prevent overloads on your system. So the RAS actually, it helps us to manage some of the congestion that's currently happening in the system. But on top of that, some of the things we're looking at as well. So we're looking at green enhancing technologies. So that would include like the dynamic line ratings, where you move away from static ratings that you normally have summer and winter, 0 degree, 30 degrees. So now we actually measure temperature, wind direction, and stuff like that, just so that we have a little bit more extra capacity on the system so that we can actually alleviate some of those curtailments. There's also some looking to smart RAS schemes so that we can centralize those remedial action schemes and be more efficient onto which generator will be affected by the RAS operation. I understand the ISO is also looking at automatic dispatch systems so that they can manage the overload on an automatic manner rather than by operator action. And then we're also looking into integrating our studies tools for operations with our energy management system, just so that it could reflect the actual power flows in the system when we're doing studies and preparing for next contingency. One more thing that's emerging now is the obviously with reduction of natural inertia, as we talked before, is bringing the best systems, battery systems, just so that they can provide fast frequency response. For sure, the ISO piloted this between 2022 and 2023, which was utilized during our tie line outages, which, by the way, the tie line is actually playing a very critical role in the system, given that with that tie line we connect to BC, which has a lot of hydro generation, which comes with natural inertia. Plus, it also helps to balance out. So if we're lacking supply adequacy, we can benefit from BC Hydro, or we have excess of renewable generation we can export to BC. So that tie line has taken a critical role in the system. And then further than that, there's emerging technology on IBRs. So most of our IBRs, as I mentioned before, the currently ones in our system, they're grid following. So they really need that voltage reference from the system to operate. But there's emerging technology on grid forming that they can actually generate their own voltage independently from the system. They can also provide synthetic inertia. So some people refer to it as virtual. It could be synthetic inertia. So they're almost simulating the behavior of the traditional conventional generators by basically controlling the output to simulate that inertia based on frequency variations. And then this technology could also be applied as black start, and that's something that we look forward to.
Awesome. I like that you touched on FFR, fast frequency response. That's a really good segue into the next sort of section of our discussion here. Before we go there, I'll just put a quick plug in to please continue to put your questions in the Q&A box. I see a few are coming in already. So that's really fantastic. Okay, let's move the conversation to this reliability piece that we started to talk about and FFR. The ASO has an FFR Plus engagement out. We've recently released a reliability roadmap, both of which have an implied reference for a need for battery or some sort of technology to help improve grid reliability in the province. So a quick shout out and a plug to those who worked on those files. It's really, really impressive work, and it's a lot of work. So if we're thinking about reliability, we're thinking about perhaps potentially batteries for this discussion. Tracy, I'm going to start with you here. You're here with sort of a couple hats. You have your NMAX hat, but also Electricity Canada. Are there any learnings that you can share from your involvement with the Grid Modernization Committee with Electricity Canada? How are others keeping up with the technology mix? What does that look like, sort of from your perspective?
Yeah, Electricity Canada's Grid Mod Committee, really this year chose to have a focus on how we as Canadian utilities can unlock the existing grid capacity for our infrastructure. And so lots of people have different initiatives underway for this, but really what we're finding is that one of the largest barriers is how utilities can justify these additional systems or infrastructure now in current times to prepare for the future need. So if some of these things don't get put into place, they might not be installed when we actually require them. So our largest discussion is really right now on how we look to working with Electricity Canada and advocating for advancement of these initiatives to balance our current needs that our budgets need to accommodate. So we're working towards a white paper near the end of the year that will be issued. I'm not totally certain if that'll be for public, but again, most of the utilities are learning into that. And I would just say that there's a lot of ways to get involved in some of these committees, whether you're part of a utility or things like that. And so just getting involved with the various different committees is a really good way to learn and help push those things through.
Awesome, thank you. I like the idea of the white paper and getting involved. The more we can sort of learn about this space, I think the better all become. Looking at reliability, and Mike, you're here with Infinite, who has developed, I think, 180 megawatts of the 190 megawatts of energy storage in the Alberta grid. So I'll call you a trailblazer in the battery technology space. Now, of course, I don't want you to give away your commercial secrets, but in the spirit of grid reliability, what can you share about being a first mover in this space, and how can others learn from what you've done already?
Yeah, I mean, truthfully, it was with the help of a lot of support advisors and partners to really get to the point we're at. I can't take really any credit for it at all, but I've been a part of it and can preach for them. Really, it was about taking risk, but a calculated risk in that I'm an engineer by training, so you try and take things back to first principles and look at the physics and can see the trend, like the build out that was happening, and could see that Alberta's in a tricky spot. We should all appreciate the system operators a bit more every day of what's happening and how much balancing is going on every minute. So seeing that, like, if we're not lucky in Alberta of having any natural storage in the form of large hydro, and we're weakly interconnected for the most part, that there was an opportunity there. If there's a commercially viable way to give a buffer and a way to store energy that can be used later on, that was an opportunity. So we took that risk and decided that was what we were going to invest in. And the technology also came along where it was a viable, proven technology by the time we were looking at it in 2019. So it was a bit of timing as well, to be honest.
Right. That makes sense. That makes sense. Amazing. Okay. And in the spirit of sort of this, the R3 roadmap that was put out, there's a lot of changes happening to the market in the spirit of grid reliability, RAM, OTP, TRP, every acronym under the sun. Astrid, a question for you is, what are the key features of this framework and their impact on IBRs from your perspective?
Yeah, so maybe I'd like to start with, the ISO. Like Mike said, the operators are doing a great job, but also on the planning side, there's a lot of work going on around regulatory frameworks, which is where RAM, LTP, and TRP falls. As we talked about earlier, system congestion and supply adequacy, as well as reliability, has driven the need to change the regulatory framework so that we can compensate for those new services required. And that's where, REN comes into play, so that we can actually, instead of having a single market price across the system, we can actually compensate generation based on a local market price that considers the cost of congestion plus transmission losses. So this is a big change from our typical energy market only structure, but is a positive change on the right direction, so that we can retain those resources that are necessary, dispatchable generation and firm generation. So that's the main change introduced with the REM program, is the locational market price, the LMP for the generators. There's also some changes to the price cap that would take in effect in a number of years. But the other big change as well is the addition of the new ramping auxiliary product R30, which again, this is keying towards reliability, just to make sure that we have proper allocation and compensation for these additional services that we require for fast ramping to support reliability. So there's other changes, but in my mind, those are the key ones that are related to REM. With OTP, optimal transmission planning, again, this works along with REM. So all three, REM, OTP, and TRP, they kind of work together. So the OTP is more trying to make the decision, now that we're operating on a congested system, is trying to make a decision as to where do we invest to reinforce the system based on benefit cost analysis, which I'm sure the ISO team there will be doing a lot of work on, and we're looking forward to see what those top projects are. The first one out of the list, but it's moving on the right direction. We want to make sure that the benefit cost ratio is there to invest on the right locations. And then the third one is the TRP. So basically, the TRP is just basically a replacement to the generator for the generator owner contribution, what's called a WAC. And then this one is what it does is it allocates cost based on causation. So it basically allows through this TRP is to basically generators will be contributing to transmission development as needed. So those are the three main things, and then what is the impact on IBR as a result of those three? So from wind and solar, obviously they would see larger cost as they will be contributing through the TRP. But for the BESS systems battery, lots of potential there with the new R30 ramping services.
Amazing. And in the spirit maybe of OTP and TRP, I think you did a well job articulating those. For everyone's awareness, please check out the AESO Engage page. There will be engagements on both of those topics in October, or the AESO newsletter. It's important that we get feedback from industry. Okay, so let's unpack batteries a little bit more. I do want to leave 10 minutes for time, so maybe this will be our last section, then we can have final thoughts and get to the Q&A. A question for you, Mike. Batteries are going to solve all the world's problems. Is Alberta sort of on a scale of 1 to 10 amazing or not a great place for large volume battery deployment? Like, is our cold climate a benefit or a challenge, an opportunity? How do you see large batteries in Alberta?
That's a good question. I don't think it's the silver bullet that solves all the problems, so maybe I'll start there. I'd say maybe the first thing to think about when we talk about large and how much will come is always remembering that a battery doesn't generate any electricity. It's actually a net consumer of electricity. So we have to keep that in mind. As load grows, batteries don't solve that problem. So they're a part of the solution, would be my opinion. They help in lots of little niche ways, but it's important to understand the scale of our grid as well. We can't make comparisons to California and ERCOT in Texas and say, well, we should have this much battery. It's very different. The circumstances are different. So I do think there's space for the industry to grow in that way, but it's going to depend on finding the right balance to match the needs of the system. We shouldn't arbitrarily set a target of there should be this many megawatts or gigawatts, whatever. I don't think it will be huge. But it's finding a balance. I think that's the thing we've learned the most in the last couple of years, right? And why we're going through REM and OTP and all this, we ought to find the right balance. So kind of a roundabout answer, but I don't have a number.
That's okay. I like that. I like that. Okay, so recognizing maybe we can't compare it to other jurisdictions, but we could learn from other jurisdictions. Tracy, from your experience, how are other jurisdictions outside of Alberta leveraging battery technology?
Yeah, so definitely the California, northeastern United States are using batteries to store energy and also discharge energy very rapidly when required. And just because it is faster than other conventional generation technology. Some jurisdictions are using the battery storage alongside solar PV production, so it can be released at an alternate time where the energy is more valuable, prices are higher. In some jurisdictions, they're also being used, as we talked a bit about the fast frequency response. Again, this requires the rapid discharge to maintain the stability in the event of generation fluctuations. This is really needed just because of the variable technologies such as wind and solar PV when they're coming online. So we know Alberta has piloted that and looking into it more. So looking forward to seeing that, but agree it's not that silver bullet.
Okay, amazing. Okay, in the interest of time, one last question for everyone. We'll go back in the order. I'll start with you, Astrid, and then move around my screen here. We'll go to Q&A next. So this isn't, don't hang up if you're thinking about hanging up. Please put your questions in the question box. So Astrid, what is one thought or key message that you would like to leave the audience with?
So I'm not promoting SIGRE, but I did wanted to mention that if you enjoyed the session today, I encourage you to register for the upcoming SIGRE Canada in 2026. Altling is going to be hosting SIGRE Canada here in Calgary. And we'll be, inviting a number of industry experts across the world to discuss their experiences and expertise on integrations of BESS systems, data centers, green enhancing technologies, and all our current relevant topics. So if you're interested in these, and just as soon as the Montreal SIGRE Canada is done, there will be announcing the one in Calgary. So please go ahead and register on the SIGRE's website.
Amazing. Sounds very fun. Tracy, over to you.
So I think one of the things that we talked about is just women in power and some advice that we could give to ourselves as we were starting out our careers or people who might be listening today. And so one of the things that I would say is just to definitely be really true to yourself. You're going to receive a lot of advice of how to advance and what roles you should take, but figure out for yourself what you love to do, where your passions are. The industry really needs diverse roles or diversity in all our roles. And someone's view of success might not be the same as yours. So just because someone else says you should go and do this or take that, be open to it, take opportunities, but with a mindset to pursue what brings you fulfillment. And make sure you're also networking and collaborating, because that will often be the way you build connections to have new opportunities.
I love that. Defining your success, perhaps. My definition might not be your definition. Awesome. Okay, Mike, last but definitely not least.
Thanks. Yeah, I would just build off what Tracy said and tying it to the electricity industry is be outspoken, think outside the box. Don't take what anybody tells you. Like, that's how it's always been. That's the way it should be. The grid's changing rapidly. Supply mix is changing rapidly. So be curious and ask questions, and don't be afraid to speak up. That's what we need.
Awesome. Okay, well, thank you, panelists, for the conversation. We are going to spend maybe 10 minutes, 7 minutes, I'm not sure, moving over to the Q&A. If anyone has a question, again, please put it in the chat. I'm going to start at the bottom and work my way up to high five those who ask questions early. If we don't get to your question, then perhaps you can reach out to Leah or any of our panelists and we can follow up afterwards. Okay, so the first question, Mike, I'm going to give this one to you. Does geothermal fall under conventional in this context? So this is going back to the very beginning of our conversation around what is a conventional generation versus IBRs.
Typically, yes, it would be. The geothermal side of it is where the heat's coming from. It can be to make steam or heat up a different working fluid and put it through a Rankine cycle, but you're going to have a machine spinning a synchronous generator typically. Okay,
I guess so long as a spinning machine, the answer is yes.
Typically,
okay.
Yes.
Provided Alberta's locationally segregated grouping of IBRs versus scattered synchronous generation, especially in potential unstable areas like Medicine Hat, do you think IBR conjoined technologies, i.e. synthetic inertia, can sufficiently provide grid reliability or market mechanisms regulation necessary? So maybe Astrid, I might put you on the spot, but if anyone else wants to jump in, feel free.
Sure, I think it's probably a combination. So as Mike mentioned earlier, so the BESS can supplement, but it's not a full replacement. So in terms of inertia, so the existing conventional generation, they will provide that at no cost. It would always be there as long as the generator is online. With the IBRs, there's actually a cost associated with that service. Plus, there's also you need to monitor and control. Like it's not automatic. It has to have a trigger. So there has to be a balance, and definitely grid forming, as well as the BESS systems. They can supply synthetic inertia, but you will still need things like synchronous condenser to complement it, or have some sort of additional generators in the system to provide that natural inertia. So it's automatic and it's also at no cost. Plus, because of the different applications of the BESS, you will need to make sure that the regulatory framework is there, because the BESS could provide synthetic inertia, or they could provide fast frequency response. So there has to be a mechanism in place to capture all those costs.
Awesome. Okay, thank you. Okay, the next one, I'm going to imply that it's battery related as opposed to IBR generically, but so Mike, I'm going to pass this one your way. With Alberta's outlook on data centers / power electronic load growth, whereby loads can ramp up or down significant megawatts in seconds, can IBRs, in your scenario batteries, sufficiently grow in parallel to provide supply while maintaining grid stability? What grid reliability challenges do you see as most pertinent to managing this change in demand characteristics?
So I would say technically, yes, a battery can do that. It's gonna, again, this kind of ties to what Astrid was talking about. Is it the most efficient way to do it, and will the costs be covered? Because nobody's going to offer that service for free. Can it grow with it at the same rate? Yes. There's lots of supply now. There's no supply chain concerns there. I think a difficult part of that is, how do you create a market that does more than one thing? The good part about a battery is it can do lots of things, and there's lots of stacking opportunities. If something is purely doing that, that's going to be expensive. And it's difficult to justify that there would be a market, and who's going to pay for it. But it really depends. I mean, a lot of that is going to get put onto the load themselves, like onto the data center specifically. So you might see a lot of behind the fence batteries to handle that, and it's not going to actually be a responsibility of anybody on the grid. It's very new and very fresh. It's tough to answer.
Yeah, that's fair. We did a good job. Okay, Tracy and Astrid, I'm going to give this to you collectively, and you can maybe riff off of each other a little bit here. Any challenges from a system modeling perspective at NMAX or AltaLink, specifically EMT models, to capture IBR's impact on grid dynamics? Do one of you want to take a stab at that?
I can start. I would just say, so I'm not really close with the planning area to answer that specifically, but I know they have had challenges. But in talks with different software manufacturers, they are starting to integrate these things in more. And I think tools are advancing where we can start to use them more, but it has been a gap and a challenge. Astrid?
Yeah, I would probably echo that. So traditionally, we had challenges on getting appropriate models for these IBRs, especially because some of the information was proprietary from the vendor. But I think we continue to enhance those models, and there's a number of researches in the industry going on. Was one of the risk flight by NERC. They actually highlighted this as a concern. But we definitely are trying to model. If the question was about ENTP, yes, we use tools like PSCAD to actually try to model these inverters. There's a number of studies. One of the things with the IBRs is like our interconnection studies are getting more complex, and we need things like PSCAD or ENTP to actually model the complexity of those control systems. And the tools are there, but we just need to understand the models of the IBRs themselves better, so that we can study things like there could be oscillations between control systems on the IBRs and things like that. So it's definitely a lot of work to do there.
Awesome. Thank you, ladies. Okay, one last call for any additional questions. I think we've been through everything I've seen in the chat, so someone raise their hand if I've missed something here. But with that, I would like to thank our panelists and everyone for joining us today. Really appreciate the fruitful conversation, and I sort of take away, the more we can learn, the better we all are. Whether that's in this IBR space or with our personal careers. So thank you for your attendance, and thank you, panelists, for joining us today.